So picture this. It's the middle of the night, early Monday morning. Most of northeast India is fast asleep, and then the ground starts to move. It wasn't some huge catastrophe, but it was this really powerful, rattling reminder of the colossal forces that are always at work, right under our feet. That was the seismic wake-up call in Assam, and today we're going to break down exactly what that tremor was trying to tell us. So what really went down in the pre-dawn darkness?
Yep, 4:17 a.m. That was the exact moment. I mean, can you imagine being jolted awake, not by your alarm clock, but by the very floor beneath you shaking? For tons of people across Assam and its neighboring states, that was a sudden, heart-pounding way to start the week for sure.
And this is the number that immediately started flashing on screens at seismic monitoring stations everywhere, a magnitude 5.1. Now, officially, that's what we'd call a moderate earthquake, but believe me, it was definitely strong enough to be felt across a huge area. But what does a number like 5.1 actually mean? Well, it's not as simple as you might think, and we're about to unpack all of that.
Okay, but first things first, let's get grounded in the facts. What did that 5.1 actually feel like on the ground? And what were the immediate details of this early morning tremor? Let's take a look. All right, so when you look at all this info, the key thing isn't just the location in the Marigan district. No, it's this number right here, a depth of 50 kilometers. Now that is incredibly important. It's pretty much the main reason why, even though the shaking was felt across multiple states, the final impact was, thankfully, zero reported damage or casualties. So yeah, it was a very real scare, but it wasn't a disaster. And that depth, that's totally central to this whole story.
So we know what happened in Morrigan, right? But to really get why it happened and why this whole region is so prone to shaking, we need to zoom out. And I mean, way out. We've got to look deep beneath the Earth's surface at the planetary engine that's driving all these powerful events.
And it all starts with this idea: tectonic plates. Okay, so try to picture the Earth's surface not as this solid, unbroken ball, but more like a giant cracked eggshell. You with me? Each one of those massive continent-sized pieces of shell is a tectonic plate. And here's the kicker. They aren't just sitting there. They are in constant, super slow motion, just floating and grinding and shifting on the molten rock below.
Now, what I love about this is how simply it lays out this absolutely colossal process. You've got these plates drifting and bumping into each other, and that builds up immense stress along their edges, what we call fault lines. Think of it like bending a thick plastic ruler. You can bend it and bend it and bend it, but you know what's coming, right? Eventually, it's going to snap. Well, the rock along a fault line does the exact same thing. It snaps, and that releases this phenomenal burst of energy in every direction. Those are the seismic waves we feel as an earthquake. Boom.
And that brings us to two words you always hear on the news. And honestly, the difference between them is super important. We've got the focus and the epicenter. The focus, that's the real origin point. It's the exact spot deep in the earth where that rock first snapped. The epicenter, on the other hand, is just the spot on the map right above it. So for our Assam quake, the focus was way down at 50 kilometers, but the epicenter was right there in the Morrigan district. Okay, let's circle back to that number, 5.1. Now you might hear that and think, all right, 5.1, that doesn't sound nearly as terrifying as, say, an 8 or a 9, but here's the thing with earthquakes. The magnitude is only one piece of a much, much bigger and way more complex puzzle. This right here, this is the key distinction you got to remember. Magnitude, that measures the raw energy that's unleashed way down at the source. That's the cause. But the impact, the shaking, the swaying buildings, the potential damage, that's the effect we feel up here on the surface. And the thing is, one doesn't always tell you what the other is going to be like.
And this slide shows you exactly why. The depth of an earthquake is an absolute game changer. The Assam event, that was a deep quake. Its energy had to travel 50 long kilometers just to get to us. And along the way, it lost a ton of intensity and spread out. That's why the shaking was felt over a huge area, but it wasn't destructive. A shallow quake, though? Whoa, that's a completely different beast. Its energy is released right near the surface, and it hits a smaller area with a much more violent, concentrated punch. It's a huge difference.
So that brings up the big question. Why Assam? I mean, why this particular corner of the world? Was this just some random, unlucky event? Well, the geological answer is a big, fat no. This region has a long, violent, and incredibly powerful history of seismic activity.
Yeah, this quote from the seismologists, it really says it all. You have to picture this geologic collision happening in super slow motion. The massive Indian tectonic plate is just relentlessly pushing northward, smashing into the equally massive Eurasian plate. And northeast India, it's caught right in that tectonic vice grip. That makes the entire region a known and very active hotspot for earthquakes.
And let's put this whole thing in historical perspective for a second, because this recent event is really just the latest chapter in a much, much larger story. If you look at this timeline, you can see the region has been rocked by some of history's most powerful quakes. Back in 1897, you have the Great Assam earthquake, a monster quake. We're talking over magnitude 8. Then in 1950, the devastating Assam-Tibet earthquake. The recent Morrigan event is just the latest tremor in a land that is, and probably always will be, in motion.
Which brings us to the final, and maybe the most critical question of all. We understand the forces at play. We can map the fault lines, we can identify the hotspots with incredible precision. But the holy grail of seismology, predicting the exact when and where of the next big one, that remains tantalizingly out of reach. So the real question isn't just about prediction, it's about preparedness. Knowing the why and the where, how do we learn to live